Hi students, welcome to our physics class. Let me tell the question. The question here, two plates are there and one plate is at V1 voltage and another one is at a different potential V2, and the first plate is quite horizontal but the second plate somewhat inclined with x-axis is making a little angle alpha, of course very small. The plate separation at the two ends of the plates, that is D. But now we go from here to here, the distance between the two plates that increases because here alpha is a little bit more. Now the question is, what is the capacity of this capacitor? When the two plates are exactly parallel to each other, already we have the equation capacity is equals to epsilon naught A divided by D, where A is the cross-sectional area. It is the direct equation. But here the distance between the two plates is simply increasing as you go from one end to another. So by considering this much distance from here to here, then what is the capacity of the capacitor? That is the question. So before solving it, let me rewrite the diagram. The first plate is like this. This is the first plate. That is in the square shape. Means this is A as well as this also. Of course, it is a square, the shape of this. Now from here, at D distance we have another plate. This is the distance D actually. From here we have another plate like this. This is another plate and this is the plate separation. Here alpha is given, that is alpha, and the shortest distance between the two plates is D. Shortest distance to two plates is D. Here. Here, let us take a smallest width out of the total. Here, from here to here, the width is A because it is nothing but length. So, out of this length, let us take a smallest width, a very smallest thickness. This is the very small value. Okay, that is of dx width from the total length. We have taken a very small area dx, and this small area from the fixed one, here it is let at x distance. This is the x distance. At x distance, this dx thickness is at x separation from the fixed. Now it looks like a strip. It looks like a strip like this. Here it is. For this one, here we have voltage V1, here we have voltage V2. This is the thickness we have taken dx. So here, this edge is at V1, this edge is at V2, and this is the distance between the two plates. And for this smallest capacitor, why it is called capacitor means here one plate is there, here another plate is there. Between the two plates we have a small layer of dielectric medium. So I am considering this is nothing but a capacitor. Like this capacitors are so many. When you are moving this side, another strip and another strip and another strip and another strip will come, and this side the smallest strips will be there. So all the strips of small capacitors are in the parallel because all the plates are at V1 and these plates are at V2 range. So out of the total area, we are considering this small area. We know that the area is equals to length into breadth. So what is the length? The length of it is, see, this is nothing but length. Here it is A, and what is it? This is the width, length into width. This length is A and this width is dx. So here length is nothing but A and width is nothing but dx. So area of the small sheet, the area of this small sheet is A into dx. And the capacity of this small strip, what we have considered, a very small strip capacity, let DC. DC is nothing but the smallest capacity out of the total. So DC, that is equals to, here what is that? Epsilon naught A by distance. Here I am writing epsilon naught A divided by distance between the two plates. So here we have already area, that is A into dx divided by distance. What is the distance? See, distance means from here to here. I am erasing this part for my convenience. So distance from this edge to this edge. But it is very clear, distance from here to here is, it is given fixed one, small d, and this is the extra one. You understand? This is the extra one. D plus this extra. But from here to here, see that from this face to this strip, this is at the x distance we have taken. That means from here to here it is x, and this is the excess part of distance. So this excess part I am taking from this right angle triangle. From this right angle triangle, I am writing tan theta is equals to this part, that means question mark, divided by this part, that is x. Here it is x. But what is theta? In the question it is alpha. Here I am taking tan alpha is equals to this extra part divided by x. So from this one, extra part is equals to x into tan theta. X into tan theta. Here it is alpha. But for the small angles, directly taken as alpha. So we can write the additional part of x, that is equals to here x into alpha. So the distance between here to here, that is d plus x alpha. The distance is d plus x alpha. X alpha. Let it is the first one. This is nothing but the smallest capacity for here only. But we have now for the total capacity, here I am writing for the total capacity. For the total capacity of the capacitor, that is C total is equals to integration of DC. Integration. And limits for integration is x is equals to 0 to x is equals to a, because we are considering all the individual DC like small pieces and we are adding in the integration. So limits for the integration 0 to a. Okay. Now let me write what is this? This is equals to epsilon naught a dx by d plus x alpha. Here I am writing integration 0 to a, that is epsilon naught a dx divided by d plus x alpha. Let us apply integration for the only variable part, that is C total is equals to epsilon naught a. Epsilon naught a integration 0 to a, here 1 by d plus x alpha into dx. This is the part we are going to integrate. And from this I am taking let d plus x alpha is equals to d. And again let us differentiate both sides. Distance fixed one 0 plus here dx alpha is the angle is equals to dt. And we can write from here dx is equals to 1 by alpha into dt. Let us write this value in this equation. Now what is the total capacity is equals to epsilon naught a of, clear, epsilon naught a of this total value. What is dx? Dx means 1 by alpha dt, 1 by alpha dt divided by d plus x alpha, that we have chosen as t. Here it is t. Since alpha is constant, I am writing it is out of the box. Here this is and is chosen for the integration. Now here that is directly epsilon naught a divided by alpha integration of 1 by x dx, like it. Integration 1 by x dx means log x. Here integration 1 by t dt, that means log t. Log of here again t. What is t? That is d plus x alpha. D plus x alpha. And limits are 0 to a. Limits 0 to a. So let us write here. This is c total is equals to epsilon naught a divided by alpha. This is substitute in the place x upper limit once minus again in the x place 0 once. So log here d plus x means a alpha minus log here d plus in the x 0. 0 into something means 0. We can write here directly d. Now log a minus log b principle. Log a minus log b means log of a by b. We can write c total directly epsilon naught a by alpha. Here log of a by b means d plus a alpha by d. This is. But again, if you write this d separately, d by d once plus a alpha by d once. So d by d means here it is 1 directly. C total is equals to epsilon naught a divided by alpha log of 1 plus a alpha by d. This is the solution. This is the capacity of the capacitor. What is given in the question? Clear?